Okay, good morning. Good morning, all the students.
Good morning, ma'am.
Good morning, ma'am.
Good morning. Can you see this presentation?
Yes, ma'am.
Right. So in the last class, we have gone through the concepts of developing a MapReduce application in Hadoop and the configuration API and how to combine the resources and variable expansion. This configuration API will help us to set the configuration where the task is going to run. So if you want to set any properties like size, weight, or color, it may not be simple properties like that, but any extra properties can be set by using this configuration API. And we also understood that if there is a core default XML file which have some default properties in the XML file, then we can override those default properties by adding our new resources using the configuration object. So we have used the configuration object and add resource method through which we have added configuration1.xml and configuration2.xml, so that if any properties are set in configuration1.xml, they will override the properties in core default.xml. And if any properties that are set in configuration1.xml can be overridden by the latest added resource, that is configuration2.xml. These properties that are added in .xml files can be used to set the system properties, can be used to set the system configurations where we are going to run our MapReduce task. In today's lecture, we are going to see how to set up the development environment, how to manage the configuration, and how to use GenericOptionsParser tool and ToolRunner. The first step is to create a project so you can build MapReduce programs and run them in standalone mode from the command line or within your IDE. So if you want to test your MapReduce programs in a standalone mode, not still on a HDFS cluster, in such cases, your first step is to create a project. So using this project, you should be able to understand whether your MapReduce program is running without any errors. Now for that, we can use the Maven POM project object model, which is a automated build model, which is an automated project building tool through which you can build the projects. So the Maven POM will show the dependencies needed for building and testing MapReduce programs. So this automated project building tool will have all the dependencies that are required for building and testing your MapReduce programs. Now for building MapReduce programs, you only need to have the Hadoop core dependency, which contains all the Hadoop classes. So if you want to run your MapReduce jobs in the Maven framework, then you have to have a dependency called as Hadoop core dependency. You have to include this dependency, which contains all the Hadoop files that will enable you to run MapReduce jobs in Maven environment. So Maven, you understood, right? It is a project object model, which is a framework to automatically build the software, to automatically build the projects to run your, in this case, MapReduce applications. Now for running unit tests, we use JUnit. In order to run unit tests at a smaller scale, we generally use JUnit, Java unit package, as well as a couple of helper libraries. What are those helper libraries? Hamcrest all. Hamcrest all has the helper libraries, which provides useful matchers for writing test assertions, and MRUnit, that is MapReduce unit, is used for writing MapReduce tests. So if you want to check any Java functionality, Java codes functionality, then you can write unit tests with using Java unit, JUnit package. Or if you want to write any MapReduce tests, then you can use the MRUnit package. Now the Hadoop Test is another library which contains the mini clusters that are useful for testing with Hadoop clusters running in a single Java virtual machine. So if you are running in a pseudo distributed mode where you're using only one machine on which all the Hadoop daemons are running, then your machine itself will act as a HDFS cluster, and we call that as the mini cluster. Now, if you want to write any tests, then you have to use Hadoop Test to write the unit test for your mini cluster. Okay, so Hadoop Test is a library that contains the mini clusters that are useful for testing with Hadoop clusters running in a pseudo distributed mode. Now, many IDEs can read Maven POMs directly, so you can just point them at the directory containing the POM XML file and start writing the code. So you have to bring all the dependencies, right? When you're working in a environment where you can automatically develop the project model, now to make that environment compatible enough to work with Hadoop or any HDFS cluster commands, for that you have to point to the directory which is containing this pom.xml file, so that all the configurations that are mentioned in this XML file will be brought into the environment that you're working in. For that you have to point your you have to point your IDE to point to this directory that is containing this project object models XML file and start writing your MapReduce code for your unit tests. Now, alternatively, you can use Maven to generate configuration files for your IDE. You can also generate configuration files by using this Maven environment also, if you don't want to use the existing XML file, that is pom.xml. Now, for example, the following creates Eclipse configuration files, so you can import the project into Eclipse. So if you want to import that Maven environment into your Eclipse environment, then you can use this %mvn. MVN stands for Maven. %mvn. Get the configurations, Eclipse configuration files by using Eclipse hyphen download the sources, all the sources that are required to build your programs, and download Java docs and enable it to assign it to true. Assign true value to D download Java docs. So hyphen D will help you to override the existing properties of the XML files. Using this, you can bring your Maven and you can bring your Eclipse into your Maven environment and start writing your unit tests. Unit tests are required to debug your code at a smaller scale. Means if you write a unit test, you will be able to see by passing that test whether it will be whether it can give the same expected result. Means say after execution of some code, if you are expecting a result, whether the expected result is equal to the actual result or not, in order to find out, in order to see that no bug is being erased, you have to use these unit tests. I'll show you how to write the unit tests in the next session. Now, in order to manage the configuration, when developing Hadoop applications, it is common to switch between running the application locally and running it in a cluster. So when we are developing the Hadoop application, we can't altogether develop it at a smaller scale, completely perfectly working fine, and then deploy it onto HDFS cluster. It is not possible. So you have to do it up to some extent, develop the application up to some extent locally, and then deploy it onto HDFS cluster. Now, if at all there are any errors that arise while executing it on HDFS cluster, come back to your local environment, debug the errors, resolve the errors, once again put it onto HDFS cluster. So switching between the application, switching between local and local application and on when it is running on cluster has to take place, and it is unavoidable. In fact, you may have several clusters you work with, or you may have a local pseudo distributed cluster that you like to test on. So you may have several clusters that you are actually working if you are doing it at a larger scale, or you may have local pseudo distributed cluster that you like to test on, means single machines that are running in a pseudo distributed mode where you wish to test your code at a smaller scale. Now, one way to accommodate these variations is to have Hadoop configuration files containing the connection settings for each cluster you run against, and specify which one you are using when you run Hadoop applications or tools. So in order to accommodate for all these variations, you have Hadoop configuration files which already have the connection settings for each cluster, and these you have to specify when you are using on a Hadoop application or Hadoop tools. Now, as a matter of best practice, it is recommended to keep these files outside Hadoop's installation directory tree, as this makes it easy to switch between Hadoop versions without duplicating or losing the settings. So whenever you have to use these files, Hadoop configuration files, always keep them outside the Hadoop installation directory tree so that it will not be duplicated again and again. When you are installing Hadoop directory once again these configuration files may be reloaded. So better keep them separately and then find access to them. Now let us assume the existence of a directory called conf that contains 3 configuration files. So under this configuration directory, you may have 3 configuration files. One is Hadoop local.xml, and one is Hadoop localhost.xml XML file, and one is Hadoop cluster.xml file. So all these XML file will have respective properties which will be used by the local system, by the local host system, and by the cluster. So they back up some configuration settings. So the Hadoop local XML file contains the default Hadoop configuration for the default file system and the job tracker. So if you are running a data node as a job tracker, then that will have all the default Hadoop configurations when you connect it to Hadoop local.xml file. Now that looks like this. When you take a Hadoop local.xml file, it may have some default file system properties and the file path to which it has been set to, the default file name that it has been set to. And it may have another property called as MapReduce.job.tracker to make a data node a job tracker, right? You know that the data nodes act as job trackers as well as task trackers. Now the job tracker will be responsible in order to monitor the progress of MapReduce jobs on task trackers, right? Multiple task trackers, task tracker 1, task tracker 2, task tracker 3, right? So the job tracker is like a leader which will monitor, even job tracker is also data node, but acts as a job tracker to monitor the progress of tasks that are assigned to other data nodes which act as task trackers, right? Now, in order to make a data node a job tracker, we have to set this property, MapReduce.job.tracker, and set it to local. In this case, you are running in a pseudo distributed mode. So the same machine will act as a name node, will act as a secondary name node, will act as a data node, job tracker, task tracker, right? All these 5 daemons of Hadoop will be running on the same local machine in a pseudo distributed mode. That is why we are setting the value to local. Now, the settings in Hadoop localhost.xml point to a name node and a job tracker, both running on local system, local host again. You understood that you are working in a pseudo distributed mode, right? So you have everything on running on the same machine. In the pseudo distributed mode, the name node, the secondary name node, the data node, the job tracker, and the task tracker, all these are running in a pseudo distributed mode on the same machine. Now the settings in Hadoop localhost.xml point to a name node and a job tracker, both running on the local host itself. This is your local host running in a pseudo distributed mode. Now what are the properties that will be set in this .xml file? First, the file system's the file system's default file name will be set to HDFS URI pointing to the local host, because all these are running on the local host itself. And you also make the job tracker to be listening on a port number. Remember, all these components, all these daemons are running on the same local host, so they should be listening to on different port numbers. Otherwise, there will be conflicts. That is why, in this case, for the local host, we are making the local host as the job tracker by making it listen on the port number 8021 to act as job tracker. Okay, this is the configurations we have set in Hadoop localhost.xml file. Now we have yet another file, that is Hadoop Cluster.xml, right? So what are the three files? Hadoop XML. Here we have Hadoop local.xml, Hadoop localhost.xml, and Hadoop cluster.xml. So what are the properties that are set in Hadoop cluster.xml? We have file system default name. Now it is being set to name node. The HDFS URI path is given as the name node, so that the same system, the same local host running in a pseudo distributed mode will also act as name node. Right? So that is set, and the job tracker now it is listening on 8021. Though it is now acting as a cluster, HDFS cluster, it still has to perform the responsibility of a name node and job tracker also. That is why we are setting the file path to the name node, and we are also setting the job tracker to listen on a port number 8021. So these are the default configurations that are set for the three XML files. Okay, now let us go to other helper classes that are GenericOptionsParser, Tool, and ToolRunner. Now Hadoop comes with a few helper classes for making it easier to run jobs from the command line itself. So if you want to pass any parameters, or if you want to pass any properties to the configuration files from the command line argument, so that they override the existing resources. In yesterday's class, what we have seen, you can add some resources to the configuration object by giving the XML files, say configuration1.xml, which contains some properties. Now, you are not sure about setting the configuration properties in the initial stage, but you want to set it later from the command line argument. Then that can be done by using this GenericOptionsParser, Tool, and ToolRunner helper classes. Now, GenericOptionsParser is a class that interprets common Hadoop command line options and sets them on a configuration object. So if you want to pass any properties through the command line, that can be done through this GenericOptionsParser to set the configuration object properties for your application to use as desired. Now, you don't usually use GenericOptionsParser directly. Remember this. GenericOptionsParser can't be used directly, as it is more convenient to implement the tool interface and run your application with the ToolRunner, which uses GenericOptionsParser internally. So GenericOptionsParser, though it is a class, it can't be used directly, but indirectly it is used at the background by using tool interface and the ToolRunner class in the front end. Okay, so for this, what do? You use public interface tool, which extends the configurable class. So this tool is used to set the properties that are declared in the XML file from the command line argument. For that, you are using public interface tool extends configurable, and you are using the run method in order to define what has to be set through the command line argument. Now this is an example for tool interface implementation for printing the properties in a configuration. So how do you do that? You create a class configuration printer which extends the configured class and which implements the tool interface. Now statically we are giving the default resources here. What are the default resource files we have? We have HDFS default.xml, HDFS site specific properties, HDFS site.xml, MapReduce default.xml, and MapReduce site.xml. So the default HDFS properties and the default site specific HDFS properties and default MapReduce properties and default site specific MapReduce properties will be added as default properties to the configuration object. Now these are all the default properties which can be overridden either by adding the resources through XML files or by passing the properties through command line arguments. Okay, so we are overriding here the run method of tool interface. The run method of configured class. So what we declare in this, what we define in this run method, first we are creating a configuration object by invoking the get configuration class, by invoking the get configuration method, and for entry, the string what we have taken, take it as the configuration, whatever is brought into this configuration object that you are taking for each value the property and its value you are taking, and get the entry as the key and get also the value from the entry object. Did you understand what I'm telling here? Every configuration object will have a property and a value. Now these are represented as key value pairs. The property that has to be set and the value to which it has been set, that is taken as the key and the value which is brought into entry object. Right now, through this entry object, having the template string for the key and string for the value, you are bringing each of those configuration properties into entry variable, and you're printing that entry dot get the key, which will print the property name, and entry dot get value, which will print the properties value. Say size 10 or weight heavy or color yellow, like that. Okay, so in the main method, finally, we call this ToolRunner.run method. ToolRunner is the class which will invoke this run method of the configured class. So ToolRunner.run, you are creating a new configuration for this printer class. You're creating a new instance for this configuration printer class, and you are taking the command line arguments which can pass properties and their values as parameters. Okay, so that will be run, and once it returns exit code as 1, it indicates that the property assignment is complete and it exits the program execution. But if it doesn't return 1, it still returns 0, it indicates that the execution of this program is under process and the properties are still being assigned to the configuration object. Now we make configuration printer a subclass of configured, which is an implementation of the configurable interface. So you have a configurable interface. This is an interface which we make here the configured configuration printer a subclass of configured. Okay, so we have to take it as a simultaneous parallel thread to understand. So we make configured as the superclass here, which has configuration printer as the subclass derived from configuration configured superclass, and it is an implementation of the configurable interface. Okay, that hierarchy you should be very clear. we have taken configuration printer as the subclass of configured superclass, which is an implementation of this configurable interface. Now, all implementations of tool need to implement configurable and subclassing configured is often the easiest way to achieve this. So every implementation of tool interface need to implement this configurable class. Okay, in order to implement configurable interface. Now, in order to implement this configurable interface, what is the approach you follow? Subclassing configured class, which is the easiest way to achieve that. So the run method obtains the configuration using configurables get configuration method. That is what we have seen here, right? Get configuration method. Now, using get configuration method, you are getting the configurables configuration object and then iterate over it, printing each property and the standard output. That is what I have explained. Each property and the standard output associated with the property can be printed. Now, the static block makes sure that the HDFS and MapReduce configurations are picked up in addition to the core ones. So if you take configuration printer's main method, it does not invoke its own run method directly. So what you have to do, you have to use ToolRunner static run method because it can't invoke by itself directly. So instead, we call ToolRunner static run method, which takes care of creating a configuration object for the tool before calling its run method. Okay, so you have to use ToolRunner static run method in order to invoke the run of configuration printer method. Now, ToolRunner also uses a GenericOptionsParser to pick up any standard options specified on the command line and to set them to the configuration instance. So what is the main responsibility of this ToolRunner class? It uses GenericOptionsParser in the background in order to pick up the property and its value that are passed as command line argument and set them to the configuration instance. Now we can see the effect of picking up the properties specified in configuration Hadoop localhost.xml by running the following command. Let us see how the properties can be set through command line argument. Now we are using the maven compile and exporting Hadoop class path so that it refers to the target classes. Now, Hadoop configuration printer, the program what we have written, you are trying to override the configuration by using -configuration. And how you are trying to override the configuration? With the Hadoop localhost settings. Okay, so you are using Hadoop localhost.xml settings and you are trying to override the configuration settings by using configuration printer. So it will fetch all the properties that have been set by default and overrides them with the arguments that have been passed through command line. Now here you are giving the regular expression MapReduce job tracker so that it listens to on the port number 8021. Now, GenericOptionsParser allows you to set individual properties by using this command. Say %Hadoop for the configuration printer, override the existing property yellow color with the regular expression color with G regular expression. This is called as grep command with the regular expression color, and the color is now set to yellow. Whatever is the previous color, now the color will be set to yellow. Means the color yellow overrides the existing property of the default color by using this -d command. Now -d option is used to set the configuration property with key color and to the value yellow. Now options specified with -d take priority over properties from the configuration file. Did you understand now? If we use this -d, then we are indicating that whatever property and the value we pass from the command line, that should take priority over the default properties that are already set through the configuration files. By adding the resources we have done right yesterday, configuration1.xml, configuration2.xml, they have some properties and those properties can be overridden by the command line properties by using this -d. That is what we are using here, right? So this is very useful because you can put defaults into configuration files and override them with the -d option as needed. Because in the initial stages, you may not be sure about what properties of the configuration object have to be set. So initially you can give them some default values and later you can override them with whatever value you want by passing them as command line arguments. Now, a common example of this is setting the number of reducers for a map reduce job via using this command. So you use -d to override. Now, what are the reduce tasks? You can set the number of reduce tasks for a map reduce job by using map reduce dot task. You can give the number of tasks. This will decide. In scaling out topic, we have seen that we can decide on the number of reduced tasks we want to include in the map reduce framework. It may be one, it may be many, or it can be none. In some cases, we may not feel to use any map reduce jobs. So if you want to mention the map reduce jobs, reduce tasks here, that can be given by the override command. Now this will override the number of reducers set on the cluster or set in any client-side configuration files. So you might have set some reduced jobs. These many specific number of reduced jobs you might have set for that cluster. It should use only these many number of reduced jobs. Or any client-side configuration files you might have set that only 3 or 4 reduced jobs should be used. That can be overridden by using this command. Map reduce dot tasks. If you give any new number of reduced tasks, this will override the existing reduced jobs in the cluster or in client-side configuration files. And the next session, that is here now itself, I'm going to cover that also because we are running out of time. So in this lecture, we are going to see how to write a unit test with MRUnit and run the test locally by running a job in a local job runner and how to test the driver. Okay, now how to write a unit test by using MRUnit. MRUnit is a package which will enable you to write map reduce unit tests. Unit test means it is like again white box testing. You have to check each and every functionality of the programs you write, right? You do it at a local scale so that every function work as expected. Then you can integrate all the functions together to form your final project. In the same way here, you're using this map reduce unit test package to write unit tests to see whether your map and reduce tasks are running according to expectations or not. The map and reduce functions in map reduce are easy to test in isolation, not on a cluster, right? When you write your map and reduce functions, better test them in isolation on a single machine rather than deploying it on a cluster and testing it. That is difficult, much difficult process. So you have to write map reduce functions in, you have to write map reduce functions on your local system and test it in isolation, which is a consequence of their functional style, which will tell us whether they are executing their expected functionality or not. Now, MRUnit, which can be imported from this URL. MRUnit is a testing library. It is a library that makes it easy to pass known inputs to a mapper and a reducer and check that the outputs are as expected. So you can pass some known inputs. So this is the input split. From this input split, what would be the output that is expected? Give them both. And if the expected output is not equal to the actual output, then you may sense some error in that map function or reduce function. Okay, so that is how you write map reduce unit test by using this MRUnit library. MRUnit is used in conjunction with the standard test execution framework such as JUnit. So you can run the test for MapReduce jobs as a part of your normal development environment. So the flexibility that MRUnit provides us is we can write our MapReduce jobs as a part of a normal development environment itself. You need not have to use a special interface in order to execute these unit tests. So how to write the test for the mapper? In this case, here you are using, you are importing all the IO exception files and all the org.apache.hadoop.io packages classes, and you are also bringing this MRUnit package. This MRUnit package, or we call it as library. Okay, so org.apache.hadoop's MRUnit package or library is brought into this program scope, which also has MapReduce's map driver class. So this MapReduce's map driver class will enable you to run driver tests that can be tested on your local system, that can be executed to test on your local system. All your MapReduce jobs, if you want to test on your local system, then you have to use this map driver class. Okay, now you are creating a test class in order to test your map functions and reduce function, whether they are working according to the expectations or not. So you are using the name here to resemble the purpose, that is max temperature mapper classes test we are writing. So you are using max temperature mapper test. Now we are giving an annotation here saying that it is a test. It is not it is not a code that has to be run at a larger scale on HDFS cluster. Whatever follows this annotation is intended to perform a test whether the mapper is executing properly or not. So you are using for this a processes valid record method. For this, you are creating a processes valid record method, which may again throw some exceptions that can be handled by the system. And see this carefully. Now, once the program starts, here you are creating a value variable of text type. Means it is a string type. Okay, in Hadoop, we call string as text. So you're creating a variable value of string type or text type as a new instance of, we are passing the entire input split here. In the NCDC data set, you have some input split with some values like with some string like this. In this string, most of the values are irrelevant for us because they may be some site code, sensor code, all these may be included. But the stuff we are interested in is only the air temperature and the year in which the air temperature is recorded. Okay, so from this raw data, you are creating a new instance and storing this entire input split in value. Now, from this value, and part of it you're storing as temperature also. Part of the input split you're storing as year, and part of the input split you're storing as temperature, and both of them concatenated together, you're storing it in value. Now, from this value string, you have to extract the year and the maximum temperature recorded in that year. Now, what is the mapper classes functionality? The mapper classes functionality is to retrieve the year and the air temperature recorded in that year, right? For that, we are using this value method, which contains the entire raw input split. Now, from this raw input split, what we are doing? We are creating a new max temperature mapper classes instance. You remember your mapper class written in Java? So that class's new instance you are taking and you are associating it with the mapper, and observe the dot here. You are initially creating a new map driver instance. This map driver is a class which will enable you to drive your unit test at the local system. Okay, that is the meaning of this map driver class. This map driver class will enable you to write unit tests to drive the tests on your local machine to test how the mapper works and how the reducer works. In this case, it is map drive. So create a new instance of map drive, and what does it expect? It expects a key value pair, and what does it emit? It emits a key value pair again. So that is a function that is taken as a function, and dot, you are using with mapper, which mapper you wanted to test, which mapper class you have written in Java that you want to test, that has to be associated with mapper here. Okay, so with mapper in the bracket, you have to pass the new instance of your mapper class as parameter. Okay, that is also passed. Dot with input value. What is the input value that is expected? That also can be given, because you have the input split, and from that input split, what is the expected output? You have to supply the driver method. Now, if the extracted value extracted value after execution of this method is equal to the expected value, then we say that this test driver is a pass, otherwise it is fail. For that, we are using with input value. What is the value that we have extracted? This is the input value you are passing. Now with output, what should be the output that has to be expected? From this, it has to extract the year 1950, and it has to extract the temperature, that is minus 11 degrees. Okay, that is expected. So 1950 is a text value, and minus 11 is a numeric value which is created as int writables instance, so which indicates integer value. Okay, so the input value is taken as this text. From this text, this is the value that is expected. Now, once this is run, see the last method that is invoked, run test. Now, when this class is run, it has to emit 1950 and minus 11. Now, when this 1950 is equal to expected value, minus 11 is equal to this expected value, then it will give pass. Otherwise, it will raise an exception indicating that the expected result is not equal to the actual result. Okay, that is how we test the mapper class. In the same way, we can test the reducer class also. For this reducer class, we are writing another method, returns maximum integer in values. So in the values that are supplied by the map phase, you are trying to find out the maximum integer value to represent the maximum air temperature recorded in every year. For that, you are creating a new reduce driver, and it takes key value as input, again emits key value as output. Now, which reducer class you are associating with this? The Java reducer class you have written already, right? Max temperature reducer. For that reducer class, you create a new instance and hand over it to with reducer method. So what does this do? It will check the functionality of that reducer Java class and see whether it is working according to the expectations or not. That is why you are associating the new instance of the reducer class with reducer method, and with input key what you are associating? You are associating with input key the year in which the air temperature is recorded, and with input values you are associating a list of values, means all the air temperatures that are recorded in year 1950 you are associating with this input values. So because it is a list, you are using arrays dot as list, and you are taking int writable 10 values, and each value can be of 5 digits. Okay, for that you are using new int writable 10 and new int writable 5 for each air temperature. 10 air temperatures, up to 10 air temperatures, the array can be the array can accommodate to up to 10 air temperatures, and each air temperature can be 5 digits long. Now, what is the output that is expected? With output, new text, the text value 1950 in this case, new int writable that is whatever are the values that can be expected from the input split passed, the key value pair passed by map method to the reduce method. Finally, run the test. Now, if you have the values that are expected equal to the values that are obtained after running this test, then we say that the reduce test also has passed. Now your mapper test passed, your reducer test passed, and you have tested them on a local machine by writing a driver program, correct? So running this locally on test data, how to do that? Now that we have the mapper and reducer working on controlled inputs. Why we call as controlled inputs? Because you have given the input and you have given the expected output and checking with the actual output. So we call it as controlled inputs. The next step is to write a job driver and run it on some test data on a development machine. Now your next step is to write a job driver to run these two mapper and reducer classes on some test data on your local machine. So using the tool interface, it's easy to write a driver to run our MapReduce job for finding the maximum temperature by year. So you are creating a class now, max temperature driver class, which indicates that you are trying to run this job on a local job runner. Okay, generally when you want to transport this job onto a cluster, in the initial cases when you have written Java program, you have just written it as max temperature. But because this is a job to be tested on your local machine by running it as a local job, you are giving the name to resemble that purpose, that is max temperature driver, and it extends the configured class and implements the tool interface so that any configuration objects have to be, any configuration properties have to be set that can be passed through command line argument. Now, you have to define the run method here, because when you want to run a program on your local system, it will invoke run method in turn. So this run method has to be defined, and in this run method you are checking for the argument list. So the minimum arguments that are required are the input file path from where the data has to be read and the output file path to where the results have to be written. Now if it is not in the same format, then get the simple name of the class and indicate that this is the format in which you have to pass the input file path and the output file path. If it is not in this format, then it has to give some exception, or it has to display some system message indicating that it is not according to the format that is expected to run this program. Okay, after that, ToolRunner is used in order to invoke the method print generic command usage and display the error message here, so that the system's error message is printed in order to give the generic command usage. Generally, the configuration object will have some system errors. Now we can override that by using this print generic command usage, so that it will display in whatever way we want the command and arguments to be passed. For that, we are using toolrunner.print generic command usage. Okay. Now after this, if the entered command and arguments are according to the format, then you have to create a new instance of the job class, get the configurations of the node on which this job is going to run, and give it the name max temperature. So this new job now is assigned the name max temperature, and it is working according to the configurations that are assigned by default. So after a job instance is created, your next step is to create a Java archive file. So you are using set Java archive file by class, and which class you are getting? From this class itself, you are getting the archive file. So you are using get class. So the current class which is being executed, that class details will be taken and it is converted into a Java archive file and packed into a job. Now, for this, you have a file input path and a file output path. That file input path and file output path can be mentioned in order to fetch the data to process and to write the results of the job after execution. After that, these are easy steps, right? Setting the mapper class, setting the combiner class. If you want to include it, otherwise you can omit it also, not a problem. But if you want to optimize the data transfer between mapper class and the reducer class, map phase and the reduce phase, then you can include this combiner class, then the reducer class, and finally set the output key, that is of text type, that is the year in which the temperature is recorded, and set the output values class as int writable, that is the A temperature in which A temperature recorded in that year. So this represents the year, this represents the A temperature. Okay, now your job is completely packed with all the tests, all the mapper, reducer classes, archive file, your output type, key value type, everything is ready with the job. So your next task is to call the wait for completion method. Call with using the job instance, call wait for completion method, and if it returns 0, still the job is under execution. If it returns 1, then it exits the execution of the program. Now, what you're doing in the main function, you are calling the tool runner to run the job. What is it? Actually, we generally stop at this stage itself, but we are also adding tool runner in this case in order to set the configuration properties that are already set in the default XML files. So you are using toolrunner.run method in order to create a new instance of max temperature driver, at the same time taking the command line arguments. So if you pass any properties and new values to the configuration object that are passed through the command line arguments, which can be taken into the tool runners method, which will be assigned to this configuration, which will be assigned to the configuration object that is running this job. So that is taken to the exit code. These values are taken to exit code. Now, if it returns 1, it indicates that all the properties are set which are passed as command line arguments. If it returns 0, still the assignment of the properties is being done. So that is given for system.exit. If system.exit gets 0, still the property setting is in progress. But if the exit code is 1, then it can exit the execution of the program. Now we can run this application against some local files and see whether it is executing properly or not. Now Hadoop comes with a local job runner, a cut down version of the MapReduce execution engine for running MapReduce jobs in a single Java virtual machine. So Hadoop always has a local job runner in order to run your jobs at the local level and see whether they are executing properly or not. Now it's designed for testing and is very convenient for use in an IDE like Eclipse. And since you can run it in a debugger to step through the code in your mapper and reducer. So you can run it in a debugger environment of the IDE itself and see whether it is raising any errors or not. Now, how to test the driver. Apart from the flexible configuration options offered by making your application implement tool, you also make it more testable because it allows you to inject an arbitrary configuration. So if you want to change the configuration, it helps us to do that by passing it as command line arguments, which will be handled by the tool interface. Now you can take advantage of this to write a test that uses a local job runner to run a job against known input data, which checks that the output is as expected or not. That is what we have written in the test driver code. Now there are two approaches to doing this. The first is to use the local job runner and run the job against a test file on the local file system itself. That is one approach. And the second way of testing the driver is to run it using a mini cluster. So instead of running it at the local file system, take it as a mini cluster and test the driver using that mini cluster so that you will know how it works at a local level and how it works at a cluster level also, but at the local system stage only. You are still not deploying it to the HDFS cluster. You are running it at the mini cluster level and checking it, how it works in the cluster scenario, cluster environment. Now for that we have written a test for max temperature driver that uses a local in-process job runner. Local in-process job runner will run on the same machine to test the code. So how we write this test here, the test method is defined here, which will create a configuration object, and this configuration object is getting its default name as the file path that is specified, and this configuration object is set to be the job tracker, where the job tracker will be the local machine itself, because it is being run at a local scale as in a pseudo distributed mode. So for this we pass the path NCDC's micro dataset. Micro dataset means NCDC dataset is too large, right? From that you're drawing a small part of it and calling it as micro dataset. So that file path is given to be taken as input, and for the output, the result of this map reduce running at a smaller scale, that result can be written to the output file path. Now you are taking file system get local configuration. Now on which system this file system structure is existing, that system's configuration is obtained by using get local configuration, and that is assigned to the file system object. Now, if you want to delete any old outputs, because you continuously keep running your tests on your local system, right? So old test output should not be existing. They should be overwritten with the new test output. For that, we are using file system.delete. In the output file, make it as true. Means delete the old output and overwrite it with the new output of the test that is freshly executed. Now, using the max temperature driver, you're creating an instance of this class as the new instance of max temperature driver. What is this max temperature driver? This class, what you have written. This is a driver class which will execute a job in local job runner and see whether it is executing properly or not. For that, you have created an instance, and for this driver, you are setting the configurations also. You can set the configurations by using the configuration object. Now, you are calling the run method using this driver object as a new instance of the string, and where you take the input to string and output to string. Means you are taking the input from the NCDC micro data set, converting it into a string, and the output means the value. The key you're converting into string, and the value also you're converting it into string, and you're transferring that to the exit code. If they are according to the expectations, then it gives 0, otherwise it gives, according to the expectations it gives 1, otherwise it gives 0. Now assert that if the exit code is 0, then the program can be terminated. Now check the output of the configuration with the output. Means it is comparing whatever is in the configuration file, whether it is matching with the output file. We can perform a check also. This will help us to know how the job is running on a local job runner. Now the second way of testing the driver is to run it using a mini cluster. Now Hadoop has a set of testing classes called, it has 3 testing classes: mini DFS cluster, mini MapReduce cluster, and mini yarn cluster, that provide a programmatic way of creating in-process clusters. So if you still don't want to deploy it onto HDFS cluster, but want to test it at the local machine itself using a mini cluster, then you are provided with 3 testing classes with the mini cluster. They are mini DFS cluster, mini MR cluster, and mini yarn cluster, in order to test, in order to create your in-process clusters. Now, unlike the local job runner, that is our first approach, these allow testing against the full HDFS and MapReduce machinery. So what is the drawback of local job runner? We will not get the experience of running your job on as if you are running it on HDFS cluster, though you are running it in local machine. But using the mini cluster, you can have the experience of running your job, though being run at a smaller scale, you will get the experience of running it at a larger HDFS cluster with the testing classes that are available for us. Now, mini clusters are used extensively in Hadoop's own automated test suite, but they can be used for testing user code also. So Hadoop's cluster map reduce test case abstract class provides a useful base for writing such tests, handles the details of starting and stopping the in-process HDFS and map reduce clusters in its setup and tear down methods. Setup will help us to establish the mini cluster, and tear down method will help us to shut down the cluster that is already set up, and generates a suitable configuration object that is set up to work with them. So subclasses need only populate data into this HDFS, run the map reduce job and confirm the output is as expected or not. So if the output is not as expected, then you have to go back, rewrite the code in order to resolve that scenario or in order to resolve that exception. But if it is running properly, then you can deploy it onto larger cluster. Now, tests like this serve as regression tests and are a useful repository of input edge cases and their expected results. So when you are testing it on a mini cluster, you will know what kind of scenarios have not been covered by the test, so that you can include those scenarios also. Once again, test your code iteratively after including that exceptional cases and see that no exceptions arise. So this is like a iteratively building your unit tests. So initially you test some cases, later you test some additional cases, later you test some more additional cases, so that iteratively in an incremental process you are checking all the cases that have to be included into your test so that it doesn't raise any errors. That is called as regression tests, and that you will be able to do with this mini cluster approach. Now, as you encounter more test cases, you can simply add them to the input file and update the file of expected output accordingly. So as you go on encountering more number of test cases, more number of exceptions that you encounter, you can simply add them to the input file and update the file of expected output accordingly, so that it will not raise any errors with the new input cases that are included. In the next coming session, we'll see how to run the job on a cluster and how to launch the job and understand about the MapReduce web user interface. So we have an interface where the MapReduce job execution progress will be shown to us, and how to understand each part of that interface, that I'm going to explain in the next class. Any doubts still here? I know that these topics are little complex, but if you see the video repeatedly, it will be more clear for you to understand.